Hello, everyone, and welcome to the Eclipse Integrated Development Environment 2023 June release webinar. Just really quickly, this is the agenda for today. Sumit is going to start, then Jonah, Mikhail, and then we'll have an open discussion. Each presenter is welcome to allow questions during their session, wait towards the end of their session, or wait till the open discussion as they desire. So first up is Alshama, and I will stop sharing and hand control to you.
Thank you. Let me just share my screen. Is my screen visible?
Yes, it is. It is displaying.
Okay, thank you. So hi all. I am Alshama MS, and I'm currently a software developer and a part of the Eclipse Kochi team in IBM. So Eclipse 4.28 comes with a number of interesting and useful features, and I will be talking about some of the noteworthy features today. So first up, we have the platform and Equinox. Now, the first feature is that the editor area now shows the most important and useful commands and their key binding when no other editor is open. So the information shown will be dependent on the selected perspective. For example, here, the image shown is that of the resource perspective. Now, if I open so this is the Eclipse IDE. So now, this will be the case for the plugin perspective. Now, if I switch to Java perspective, these are the commands that are shown. So depending on the perspective, it will show important key bindings. I'm sorry. Okay, so the next feature is the enforcement of the HTTPS protocol. So this feature actually addresses the CVE 2021-41033, that is the common vulnerabilities and exposure list. So according to this feature, all access to external update sites and their artifacts will be forced to use HTTPS, even when HTTP has been specified. The system properties p2.http rule and p2.ftp rule are used to affect this behavior. Now, the preference values that you can set for these system properties are redirect, allow, and block. You can change the enforced behavior using these keywords. For example, if you add -dp2.http rule equals allow as the last line of the eclipse.ini file, then the HTTP behavior will be restored. Alternatively, you can also specify these protocol rules if you navigate to the install/update option under Preferences tab, as is shown in the image. So the default preference value for each of these rules is determined by the corresponding system property. The next feature is tracking of trusted hosts. So in order to address the CVE 2021-41037, all access to external update sites as well as their artifacts during installation and updates will be tracked and reported so that you are made aware of the source of the content that is being installed, and you can decide whether to trust content from that source or not. So this is actually providing an additional level of security in addition to the signing of artifacts. Simply installing content, even without actually installing any associated artifacts, can actually reconfigure the installation, and this can even be used for malicious purposes. Also, simply because an artifact is signed, it doesn't imply that the artifact is necessarily trustworthy. The source of the installed content should also be validated before you install that content. So the following trust authorities dialog will be displayed, which will show the sites that have been contacted, details about these sites, and details about the specific content that is being installed from each site. So only those content that originate from sites which the user will accept as trusted will be installed. There is also an option to remember the trusted authorities, which is shown in the image here, so that the user will not be prompted each and every time. Now, the system property p2.trusted authorities can be used to specify the list of authorities which can be considered as trusted. The next feature is the PGP key revocation handling. So in case a PGP key is compromised, such a key can be revoked. So artifacts that are signed before the revocation date will still be valid, but an attacker can always create backdated signatures. So in case of any artifact that is signed using a revoked key, and in case of any internal exception that occurs while processing the revocation information of the key, will lead to such an artifact being treated as a suspicious one, and a trust artifacts prompt as shown on the image will appear on the screen. So one can then choose to install content from such an artifact or not, and they will be reminded of the risk. For example, here there's this prompt, trust revoked PGP key confirmation, which will remind you of the risk involved. The next security precaution is the modification of the cancel option in the trust artifacts dialog. So whenever the trust artifacts prompt where you can choose to allow or reject the unsigned content, as I mentioned earlier. So when this appears, if you choose to reject the content, that is, if you press cancel or close the dialog, any of the prompted artifacts that have been downloaded during the current install or update operation will automatically be removed from the disk in order to avoid the caching of untrusted artifacts. Those were the features in Platform and Equinox. Next, I'll be talking about Java development tools. So the first one is call hierarchy on control kick. So the open call hierarchy feature has now been added along with other options such as open declaration, open implementation, and so on, upon pressing the control key and clicking simultaneously for different fields and methods. Next is a new sub option that is available for the Java.doc HTML formatting. So when the formatter option format HTML tags under comments is selected, the default behavior for the block tags is to put each tag, that is the opening and the closing tag, on separate lines. For example, the image that I have shown now is that of an unformatted Java doc, where you can see that the opening and the closing block tags are on the same line. So a new sub option, do not put the block tags on separate lines, has now been added. So this will specify not to do or not to enforce the previous behavior, and instead have these tags start on a new line and have their closing tags end on the same line. So here the first image that I have shown shows the previous behavior, which is to add the opening and closing tags to separate lines after formatting. But according to the new feature, the tags will be put on the same line after formatting, as is shown in the second figure. So the next feature is a new name preference for the run and debug launch configurations. For launch configurations, a name is often generated on behalf of the user, which is simply the type name of the Java application, the Java applet, or the JUnit test class. So in some instances, a user can have classes with the same name in different packages or projects. So creating launch configurations for each will reuse this type name and just add sequential numbers for each of the successive configurations that are created after the first one. Just by looking at the run configuration or the debug configuration dialogs or the pull down that appears in case of run or debug, it may be difficult to determine just by the name what type of configuration it is referring to, that is, which project or package that it belongs to. So in order to solve this, a new set of preferences has been added to specify that the launch configuration name generated should use the fully qualified type name. So once this has been set, the new configurations, which are either manually created or as a result of specifying run as, debug as, etc., from the context menu, will qualify the generated name, and this will in no way affect the existing configurations. So to specify the new preference, one has to go to the launching option under Java on the preferences page as shown on the image. You can then check the option use fully qualified name in order to make use of this feature. So upon launching a Java application, you can see that the name generated in this case is test.testjavadoc, which is the fully qualified name. Next up, I'll be talking about some of the features in plugin development environment. So the first feature is automatic manifest generation. Users can now automatically generate a manifest file. While you're creating a new plugin project, you have to select the standard OSGI framework type and then select generate OSGI metadata automatically for this. I can just show you an example. Here, if I am to create a plugin project, and say name it as sample U1. Here, I'll have to select an OSGI framework, set it to standard, and then check the generate OSGI metadata automatically.
I'm sorry to interrupt, but the dialog wizard hasn't appeared when you did it. So we only see the main Eclipse window.
Oh, I'm sorry. I think I'm selectively sharing. Is it visible now?
We can see
we
it now,
can see
yes.
that. Thank you.
Oh. Okay. So, yeah. So what I did was, I created a new plugin project with the name sample new one. And I set the OSGI framework as standard and checked the generate OSGI metadata automatically box. And here you can also set the version, name, etc. And on clicking finish. So here you can see that the manifest has been automatically generated. Now, so that was automatic manifest generation. So next is the manifest cleanup action. So it is now possible to organize the manifest by either directly clicking the organize manifest header icon as shown in the image, or you can alternatively select a number of projects and choose organize manifests option from the plugin tools as well. So here, an organize manifests wizard will open up where you can choose recompute import package under dependencies. So upon completing the wizard, the manifest will then be transformed and the result can be viewed. Next is autocomplete feature for the build.properties file. So PDE now supports auto-completion of various keys in the build.properties file. The user need not remember the complete word in the build.properties header specification. They can just start typing as much as they know and invoke the auto-completion key binding, usually using control space, and thus obtain the list of potential valid headers which match the user's intent. I can show an example. So here, if I create a plugin project, and choose a custom template like hello world command. And if I go to the build.properties file, I can just start typing, for example, S. And if I need suggestions, I only have to press control space and then possible suggestions will pop up. So this is the autocomplete feature in the build.properties file. Now, the next feature is schema and feature compiler support in project-specific settings. So earlier, the project-specific preferences contained only the plugin compiler or the manifest compiler setting, while the schema and feature compiler settings were available in the workspace-wide settings. This restriction has now been removed, and all the compiler settings, namely the plugins, schemas, and feature and update site settings, are now available for the project-specific preference as well. So with that, we have come to the end of the presentation. So I would also like to make use of this opportunity to say that all of these features, it's all a combined effort of everyone associated with the community. And being open source, we are always looking out and ready to help anyone who would like to learn about and contribute to the IDE. So thank you.
Thank you, Osama. Next, we have Jonah.
Hi, thank you. Yeah, that was a great presentation. I'm feeling extra nervous going after that now. All right, let me see if I can share this and you can all see my screen, hopefully now.
Yes, we do.
Wonderful. Let's go to the beginning and start presenting. All right. Welcome to my talk today. I'm going to talk about some upcoming stuff, which is available as a preview release today. But it's integrating ClangD and Eclipse IDE using the now being actively developed CDT LSP plugins. My name is Jonah Graham. I'm the Eclipse CDT project lead, and I have the honor today of presenting the work of a whole bunch of people in the community who've been working really hard to get us to this point. That's quite an honor for me. All right, so for those of you who don't know, I'm going to talk a little bit what ClangD is, a little bit what CDT is, say why we want to do this, and tell you, who, when, where, and I have a short demo of some of the main features, and then I'm going to encourage you all to get involved. So what is ClangD and Eclipse CDT LSP? So ClangD is a language server that provides the C++ support for your editor. It's part of the LLVM project, which you may have heard of. It's used for a variety of things. Now, language servers work with the editor of the IDE. They provide the advanced editing features. So it's one way of providing the command completion, code navigation, refactoring features. Now, language servers require support in the IDE, and for the Eclipse IDE, the Eclipse LSP for E project does most of the heavy lifting on this. So the Eclipse, where does Eclipse CDT LSP fit in? Eclipse CDT LSP provides some generic C++ language server support building on top of LSP for E, and it has a specialized support for ClangD. So you might be asking, well, why ClangD? Whoops. Why ClangD and Eclipse IDE? Why is this important? As you may know, language servers, most people immediately think of VS Code. But we have, especially in the CDT community, a huge number of ISVs that have significant investments in the Eclipse-based solutions. And so we need to maintain that. There's a lot of extra tooling like configuration wizards, advanced debug views, and having good quality C++ support in Eclipse is really important. Unfortunately, the standard CDT support for C++ has not kept up with the language standards over the last few years. So it's great if you're using the older languages, older version of the languages, but if you want to use C++ 20, it might cause more of a problem. So using ClangD allows us to leverage the best of open source out there and continue allowing ISVs to deliver good products and our users to have good quality C++ experiences. All right, so who and when? So the integration of ClangD into Eclipse is part of the Eclipse CDT project. While we're developing it, we are contributing as much back to the LSP for E project so all language servers can benefit. And the CDT LSP component of it is the customizations, which are how to integrate ClangD specifically and the ClangD extensions. The technical lead for this integration is being done by Gessa at Bachman, and she's done amazing work over the last few months. And in the last in the last 6 weeks, CDT LSP has joined the CDT project, and so there's a lot of other companies and individuals involved as well. So the good news is we now have preview builds available. There's a link there to the setup instructions, but it installs like a normal P2 site. And we're naming for an initial release in the 2023-09 timeframe. Right, let's do a little demo of how this looks today. So as a starting point, I have Eclipse for C++ developers, and I've installed the CDT LSP support from the update site in those instructions. In this example, this first simple example I want to show you, I've created a simple hello.
To interrupt, you're not sharing.
What? I think I pressed the stop share button by accident. Thank you for letting me know. Okay. Let's hope I don't press that one again by accident. Okay, so here I've created a simple Hello World project using CDT CMake template. I've added a very small amount to it so we have something to demonstrate. And I've set the preferences so that we say we want to use the CDT, the LSP editor instead of the CDT editor, and so we get all the language server features. So when I open the editor, you might, if you're familiar with CDT, you might recognize this looks a little bit different. The colors are a little bit different, for example, in the syntax highlighting provided by TM-free. So in the editor, you start getting many of your normal features you'd expect. So for example, if I hover over items, we get the detailed pop-ups provided by ClangD. We have features like outline that we can navigate through our code. We have the quick outline with Control-O that also allows us to do the same. And we get some refactoring features already kicking in here. So we can do renaming of symbols. So I can say something, and we get wizards which will feel familiar to Eclipse users, but taking advantage of the LSP ClangD backends. We have command completions. So if I start typing printf, oh, great, didn't work in my demo. But I mean, you see lots of command completions in here that are all working as expected, and a bunch of other similar features that you generally expect from any advanced editor like CDT. So let's just get rid of our syntax error there. And as I go through this demo, you'll notice I'm going to switch what the editors I'm using this view down here. Quite excited to see that Myelin has returned to the Eclipse ecosystem. And when you're organizing something like a demo to show people, you can organize all of your different sets of files and click through them on there, and it keeps you quite well organized. So for the second little demo, I want to show what happens if you've got two projects that have different tool chains set up. So I created two Hello World programs, but on this version, I've set it up to use the ARM Linux compiler, where on this version, I've just left it with a default compiler. And where this is important is when you do something like control-click, let's close these for a second, but when you control-click on Open Declaration, you'll see that we're going to the x86 host version when we are using this project. And when we open this project and we click on Cout, you'll see that we're opening the ARM Linux version of those includes. So ClangD and Eclipse all understand how to maintain those different contexts as expected. So those are some very simple programs. Let's dive into something a little bit more complicated. So as I mentioned, ClangD is part of the LLVM project. And so what I have here is all of LLVM imported as a project into CDT. And so I can show you some of the more advanced, the features on some more complicated projects. So, we can see our outline here is complete, is bigger and complete. And we can start seeing some other, I'm going to start showing some other features. So for example, let's introduce an error in here. So as expected, for anyone used to Eclipse, we get the error markers that we normally have, the red squiggly underline. Hovering over the error will give you details of the error. And if there's a quick fix available, it will be provided here. So here we're just missing the brackets I just deleted. So I can add that back in and it's resolved. One of the other features you can see here in a number of places is the lightly colored parameter names of all these methods are shown. And that's a feature that actually we get from ClangD that we don't even have in CDT. So this is one of the places where ClangD is actually giving users a better overall experience as well. We can do things like toggle between the source and headers. So this is just going to, there's a pretty big file, so it's going to calculate that up. And so if we control tab, we can swap between the source and header for an implementation. And all the other kind of navigation features of control click will work as expected, as you've come to expect. ClangD is also integrated in here as well. And so I'm going to introduce an error for the coding standards here, and I'm going to give this variable lowercase t, whoops. And you see here we get a warning. The warning is, invalid case style. It needs to start with an uppercase. And once again, a quick fix is provided here. As you see, we're still in early days, so there's a few little places where we have some errors. In the GUI here, for some reason, I have uppercase T, but the uppercase T didn't draw there until I click close to it. So I think there's a little redraw error there that we'll have to resolve before the full release in September. We also have features like deactivate, like type and call hierarchies. So if I open up the index.h file here, oops, and so if I press F4 to get the type hierarchy, we can explore the type hierarchy. And we can explore the call hierarchy here. So open the call hierarchy, and the call hierarchy then displays up here. We can navigate around to the different locations. So that's a quick overview of the demos. And so the next stage is for you all to get involved. You can try it out yourself. There's a link there to the GitHub page with some setup instructions. You can check out the code and contribute back. If you just want to get in touch, the mailing list or a GitHub discussion or issue is a good place to start. And the CDT project runs a monthly call, which everyone's invited to. It's not just for committers or anything. And it's a good place if you want to just kind of come see what people are talking about, have questions about how to implement CDT itself or extend it. It's a great place. Or just come around, come lurk and listen into what we're doing. Well, thank you very much for today. And with that, I pass it back over to Gerald. Oh, you're muted, Gerald. Sorry.
Wow, okay. Too many mutes. Thank you. Thank you so much, Jonah. And now we have the last presenter for today, Mikhail. I want to make sure that you can connect and unmute.
Okay,
and let's go ahead and get started. Thank you, Mikhail.
Okay, thanks. Hello, everyone. I'm Mikhail Isuya. I'm working for Red Hat on Eclipse IDE at large, and mainly these days on LSP4E, language server integration, and the Java integration of of JDTLS in Eclipse IDE. And that's what I'm going to tell you about today. For a starter, I will show you a demo that it's a video demo that I've recorded a few days ago that I'm reusing. And this demo will go through the features of, quickly go through the features of the integration of JDTLS in Eclipse IDE. And after this demo, I will explain why we've done it, what we expect as benefits, as potential pitfalls, as opportunities, and so on. But let's start with a demo. Hi everyone, in this demo I'm going to show you the current state of Eclipse IDE JDTLS, which is a repository under Red Hat developers, which brings Java editing support for Java in Eclipse IDE using JDTLS. So this can be installed with the usual way of installing in Eclipse IDE, following a link that will open the installation wizard or going through the marketplace website, which will bring the link, the same links and so on. Once installed in the Eclipse IDE, so here I have my Eclipse IDE instance where the plugin is already installed, as you can see. com.redhat, it's this one. So when it's installed in the Eclipse IDE, it integrates in a working workbench. So I can open a Java file, and what you notice immediately if you're familiar with Java edition in Eclipse IDE is that the editor looks different. It's indeed a different editor that is used. It's not the usual legacy Java editor that we can see here. It's another editor which has syntax highlighting coming from TextMake grammar and the edition assistance coming from the language server. So we can start typing things in this editor and we get the usual feature one would expect from an IDE, such as completions and validations and so on. So here let's, for example, create a table of strings and we get some completion. So for example, the array completion is exclusive to JDTLS. It's not part of the JDT editor. And so all that is provided by JDTLS. There is no direct interaction with JDT in this editor for things like completion or things like hover or things like diagnostics. So we will just have a look at the quick features. So here we have hover. We also have go to definition. So if you control click on equals, it brings you to the definition in the reference class and all the usual feature of a good editor. So all this is provided by JDTLS, and one interesting aspect in this integration is that the diagnostics are integrated as Eclipse markers, so they can be shown on in the UI, in the Project Explorer on the left, or in the Problems view, just like it has always happened with the Java editor. And since those diagnostics are problem markers, the cool thing is that the code actions in JDT world will happen to be rendered as quick fixes and quick edits in Eclipse IDE, just like it's happening for the editor, for the legacy Java editor. So there are some other operations that most of LSP operations are actually supported in Eclipse IDE. So for example, you get also the support for rename using the JDTLS language server, and rename just works. So
Yeah, we won't show much more here. The interesting point here is to notice that everything is working um, just as expected using JDTLS. And an interesting thing is that we made the choice to run JDTLS in the same IDE process, in the same process as IDE. And JDTLS can benefit from extensions provided by other plugins, such as plugin development or web tools, which usually contributes things like ClassPass extensions, ClassPass container, or some other utility. And thanks to this approach, it means that if you install in Eclipse IDE one plugin that does contribute to JDT core, for example, contributing a ClassPass container type, then this extension works without any particular integration effort in this editor. For example, here we are referencing some API that comes from the plugin development environment container. It's not part of a pom.xml or whatever. It's specific to Eclipse plugins. And this extension, this ClassPass addition, is possible because we have the plugin development environment installed in Eclipse IDE, which is fairly easy to do. And it is easier to install extensions for Eclipse IDE to enrich the Eclipse Java editor and this generic editor based on JDTLS than it is, for example, in VS Code, where there is not an easy way to add extensions to the language server. So the current state is that the editing experience is really good. I'm personally using it all the time. And we are in the process of replacing slowly the JDT UI editor. Thanks.
Okay, so I'm done with this demo. Now I share my screen to give a few details about the internals of this integration. So share screen. Okay, now hopefully you should see my screen. So why and how we did that? So before we move on with what we consider as a possible future approach, let's look at the current state of things with Java development in Eclipse IDE. So this is a coarse-grained architecture of Eclipse IDE for Java development. So we have Eclipse IDE, of course, which provide a common model for many things. The most important one here would be resources, for example, so the state of files, the state of documents, and so on. And we have the JDT, M2E, and buildship core parts, which manipulate this model to compute the language logic, so and the build tools logic. So the core parts have the real logic that make that users can have good assistance thanks to another layer, which is the UI block. So there is a UI for JDT, for M2E, for buildship, which orchestrates the core bits to show the interesting parts, the completion, the hover, and so on, to the user through the standard user interface. So this is the current way of things in JDT and M2E and so on. And I will show how so far we've integrated language servers in Eclipse IDE. So when I say language servers, we have many examples of such in Eclipse ecosystem nowadays. There is the TypeScript, JavaScript, HTML, CSS one with a wide web developer, XML one with wide web developer using the Lemmings language server. We have Eclipse Corrosion project, which provide Rust edition with Rust Analyzer, Eclipse OmniSharp for Eclipse Acute for C# using OmniSharp language server. The POM editor is using a language server as well. It extends the XML language server, Lemmings. And as Jonah demonstrated a few minutes ago, CDT LSP, which is one feature of CDT, is also using ClangD as language server. So the integration is pretty similar, except that we don't have dedicated UI blocks. We have LSP4E, which does take care of the integration between the language server and the UI. And usually the language server is deployed as a separate process, because most often the language server is not related to Eclipse IDE. It's often not even written in Java. It can be written in any language. And the standard of interaction happens with the language server protocol, which is a message exchange format between a client and a server. So usually the language server is a separate process and the IDE is another one. They communicate via LSP messages between distinct processes. And there is just one bit, which is the LS language server integration, which takes care of embedding or binding the client and the server together so that they interact. So it's usually a couple of classes to say, here is how you start the language server, how you connect to it, and that's all. On the other end, we have here JDT language server. So JDT language server is an Eclipse project which implements the language server protocol for Java development. And this language server uses, it's an Eclipse application, which uses the common Eclipse model, including resources, of course, and JDT core, M2E core, build ship core, the core parts, to create the good answers to LSP requests or to create the good notifications according to the state of the project you're coding. So it analyzes your code and it sends the right information at the right time. So this is JDT-LS. And the approach we've taken for this integration is that since we have two Eclipse applications and they have resources in common, we decided to deploy the language server inside the Eclipse IDE in the same process. So it's a thread pool. There are more than one threads. But this language server basically replaces the core parts and everything else still interacts with the same common Eclipse model. So there are some benefits with this approach, is that we have a higher factorization in our development. Most of the maintenance is not on specific UI, but is more focused on reusable bits. So the core parts, the Eclipse model, LSP4E, the Eclipse UI. So we have really a higher factorization. And one good thing as well is that LSP in general gives a higher separation of concerns and expertise. So it happens that in our community, we have different type of contributors who have different expertise, different interests. And usually we can see that there are some people who are more language experts, who are very skilled at, for example, Java compiler, and things like that. And there are people who are more user interface experts, who are better at putting the right dialogue at the right place and so on. And this LSP approach allows a better separation between both, which allows the people to work on what they are the most interested in and the more efficient in doing more easily. And we have those benefits apply as well to the deployment we've done in Eclipse IDE JDT-LS. One expectation with such a better factorization is that basically for tools developers like about all of us in this call, we can expect that we make a better return of investment of our work. So since the work we are doing is more reusable, we create more value for the same amount of work. So we generate more value and make this value more widely accessible. Concretely, if you work on client side, so on Eclipse platform or LSP4E, or it could be in another IDE, it could be VS Code even. If you work on a client side, you don't improve just your own integration, you improve the whole ecosystem of language server-based integration. When we find issues in LSP4E or in platform working on Eclipse IDE JDT-LS, we fix them in LSP4E on in platform, and it serves the ClangD language server integration that Jonah demonstrated. All that is connected, and these factorizations allow to focus on on the parts that make sense to a wider ecosystem, not just your own use case. And similarly, if you invest some effort here on JDTLS, which is at least our case, the effort you invest in JDTLS, they will serve all editors that do use JDT language servers, so it will be Eclipse IDE, VS Code, NeoVim, and so on. And even since many of the changes that happen in JDTLS are actually happening in JDT core, most improvements of JDTLS are JDT core improvement, and that benefits as well to JDT UI. So by working on a language server on the most factorized parts, you work on everything at once. And that is the expectation and the reason why we've taken this choice to follow that path for our future development. The very good thing with this approach is that the language server based and what I call the legacy, in the sense that it's been here for long, I don't want at all to mean it's obsolete. It's still current, but the language server based and the current architectures can cohabitate easily. They just are side by side, and each one adds their own editor, their own commands, and so on. But there is no conflict actually happening. And the very cool thing is that there are no conflicts. That's cool, but even better, since both will use the same underlying model for resources, documents, and so on, there is a very strong synchronization between both. So if you switch between the language server and the Java language server based editor and the traditional JDT UI editor, it is the same document, and any change you do in one of these editors will be visible in the other. So with that, you can easily switch between one and the other. And the good thing with that is that first, if we imagine that we are in a migration process, the fact to be able to cohabitate between where you're from and where you go is pretty reassuring. If there is one feature that is missing or buggy in one of the editors, you can use the other. You're not blocked. You cannot be blocked actually. And this allows a more progressive transition away from JDT UI. If it is your goal to adopt language servers, then cohabitation allows you to do it safely. A very cool thing for tools developers who are developing this integration is that you debug as Eclipse application and you debug the client and the server simultaneously. If you have experience in integrating language servers, usually you have to debug the client, start the server in a debug mode, bind two debuggers, one for each language, and it's doable, but it's trickier. Here, it's really developing regular Java applications. So the maintenance of this integration is quite easier than usual with language server approaches. A very strong benefit that I show in the demo is that we have all extensions to JDT core, usually something like LastPass extensions from plugin development and facets. Everything that extends JDT core also extends JDTLS. So it means that if you install only Eclipse IDE with JDTLS and don't have JDT UI, but you install PDE core, then you can do plugin development without PDE UI. You can do Java development. You can do plugin development without the current Java editor from JDT UI. So this integration keeps the whole historical ecosystem usable, which is a necessity for the sustainability of the project. And another benefit, which I may be able to demo a bit later, is that most of the integrations in Eclipse IDE with the Java editors, things like, for example, the debugger, things like SonarLint and so on, they are still working with JDTLS because they are integrated on the lower level of JDTs, are not integrated on UI layer, but on core layer, on resources or JDT core. And these integrations keep working on JDTLS. I will show you that at the end of my quick presentation. Here is the link to the project. Let's click it together. Will it work? Mhm. Okay, so here is the GitHub page for the project. So it's Red Hat -developer Eclipse JDT LS. It's a very small amount of code. It's a few classes really, because everything is here more or less, because it's really only an integration, and it's currently MIT license. It's under Red Hat Developer Organization, but it's not meant to be a Red Hat only project. It's just that we wanted to start somewhere, and we may move to Eclipse organization sometime later when there is a clear benefit from it. But currently, as it's mostly me and a few colleagues, there has not been much pressure from the community to move out of Red Hat developers. And I don't know if I mentioned it, the license is MIT, and you can contribute as usual with issues, pull requests, and whatever you like. That's all for my presentation. I don't know how good or bad I was with timing.
It was excellent. Thank you, Mikhail. We are near the end, but I want to give the audience a chance to ask any questions. And I also, while we're waiting, any questions, and you can just unmute yourself. I want to thank our presenters again. Thank you, Elshama. Thank you, Jonah. Thank you, Mikhail, for coming forward and showing what's new and upcoming. I also want to encourage everybody on the call and listening to the recording later to actually go check out the projects, not just watch the video, but see the project, see where it's going, see where you can contribute. I don't see any hands up or people coming off of mute. So at this time, I think that it's close to time, and we'll just go ahead and let everybody go. Again, thank you, presenters. The recording will be up on the wiki page and on the site once we do some post-processing. Thank you, everyone.
Thank you, Gerald. Thank you for organizing.
Thank you very much.